Hello, I'm Danyil, a hardware engineer at Droid Technologies. I specialize in designing digital and analog PCBs. My responsibilities include schematic and PCB design, signal verification, prototype testing, and preparing the hardware for certification and mass production. In this video, I will guide you through the full process of post-assembly PCB testing, from signal verification and power-up procedure to debugging and hardware bring-up. The signals verification process starts from dealing with the assembled PCBs. The engineer establishes a connection between a laboratory power supply with a current limit and sets the appropriate input voltage. Then he checks the voltages and currents on each critical part of the PCBs using a laboratory multimeter. Based on the obtained results, he creates an errata document and makes any necessary fixes on the current PCB, such as soldering some components, wires, and so on. For the circuit protection testing, our engineers perform tests on all input-output pins of the PCB, according to the PCB requirements. For example, they perform testing of the maximum input voltage, ESD testing with a high-voltage generator and well-equipped laboratory, polarity reversal testing by switching the polarity of the input source, and so on. Upon evaluating the test outcomes, the errata document is updated accordingly. For low-power devices that use batteries, this process proves to be the most time-consuming, because our engineers conduct comprehensive power consumption testing and current measurements for all work modes of the device: work, idle, sleep, and deep sleep modes on each critical component. Then a table with the results is generated and compared with the theoretical calculations based on the datasheet. If the results differ significantly from the theoretical expectations, the engineer identifies the component that caused the discrepancy. Sometimes this requires resoldering components or cutting soldering some wires and schematic PCB updates. For devices that include an RF component on the PCB, antenna matching testing is essential. Our engineer connects a vector analyzer directly to the input-output RF circuit with an antenna, excluding the transmitter IC, and checks the impedance characteristics at the working frequency. Usually, the impedance should be approximately 50 ohms at the working frequency. If not, the appropriate components for the RF circuit must be selected to achieve 50 ohms. Before the design phase, a simulation of the output RF circuit is critical. For more details, check out our other video on the antenna matching process. Functional testing with test firmware is a very important step. Once it's confirmed that the device does not have any potential power and connection issues, the engineer proceeds to conduct a functional testing using test firmware that checks each hardware-dependent part, for example, a temperature sensor, memory, interfaces, and then the engineer creates a test log with the results. We start to do heating and temperature range testing when we have a fully functional device and the test firmware. The engineer places the device inside the thermal chamber and changes the temperature from the minimum to the maximum working range, employing slow speed and small increments. Based on the testing, the engineer creates a detailed report with results. For more details, check out our other video on the thermal testing. One of the final steps before certifying the device is to conduct pre-testing in a laboratory. For this, we use a spectrometer, equipped with different antennas for various frequencies. We check the spectrum of the device in the different work modes and make sure it fits within the allowed range. For this, we rent an external laboratory for the full EMC and EMI testing. For more details, check out our other video on the EMC testing process. PCB testing is a specific and complex process, especially when the goal is to bring the device to mass production. At Droid Technologies, we're here to assist you with your embedded design projects, covering electronics, firmware, software, and mechanical design to ensure successful implementation and optimal results.